Case 2017, paper 2, question 3. So you got ABC is a triangle where the coordinates of A and C are 0, 6, and 4, 2 respectively. G, 2/3, 4/3, the centroid of the triangle. AG intersects BC at the point P. And AG, the ratio of AG to GP is 2:1. So AG represents BC at the point P. That means AC goes all the ways until AP hits here, and you get a point P. What they're saying the ratio here is 2:1. They want the coordinates of P, so this is clearly the use of our ratio formula. So let's have a look at our ratio formula. So a ratio formula down here, this side of page 18 of the tables, you've got bx1 plus ax2 all over b plus a, comma by1 plus ay2 all over b plus a. Okay, so let's just be very careful what we have here. I'll draw it as a straight line. Redrawn the line A to P horizontally, 0, 6 at one end. You got the point P at the other end. So for our formula, it's the either end of the line is your x1, y1, your x2, y2. And the middle point here, this will be the answer. So we have the answer. So let's fill them in to this equation here. Our A is going to be 2 and our B is going to be 1. So fill in the formula. So when you set up your formula, you have it as follows. And now just simplify your top lines. Simplified then, it's clear that 2 times x2 over 3 is 2/3. And that's 6 plus 2y over 3 is 4/3. So you can work out your individual pieces from there. So obviously 2x2 over 3 is equal to 2/3, so we can ignore 3's underneath. So 2x2 is equal to 2. Dividing both by 2, I can see that x2 must be 1. On the other side, I can ignore my 3's in the bottom, so they're both divided by 3. So I've got 6 plus 2y2 equals 4. So 6 plus 2y2 equals 4. So 2 times y2 is equal to 6 take 4, which is minus 2. So then dividing by 2, y2 is equal to minus 1. So our x2 is 1, our y2 is minus 1, so the coordinate of P is going to be 1 minus 1. Part B, find the coordinates of B, this last vertices here. This is we're going to use the fact that G, 2/3, is the centroid. The centroid has a specific formula. Formula is as follows: x1 plus x2 over 3, y1 plus y2 plus y3 over 3, and that will give us the answer of 2/3 and 4/3. So we need to label the vertices of our triangle x1, y1, x2, y2, and we let the one we're looking for be x3 and y3. So let's fill in those into our formula and see what we're left with. Once you fill in your coordinates, then we can simplify our top line. And then what we can do is we can let our x coordinate equal our x coordinate and our y coordinate equal our y coordinate. So when you put those, obviously they're all over 3, so you can kind of ignore the 3's a little bit. So 4 plus x3 is 2. So x3 is obviously going to be minus 2. You got your 8 plus y3 is going to be 4. So y3 is going to be minus 4. So our coordinate of B is going to be minus 2, minus 4. So the next part is to find the prove that C is the orthocenter of the triangle ABC. So we'll just find the orthocenter. The orthocenter is very simple in what it looks like. The orthocenter, you take a point, any point, so I'll take B, and you draw a line from that point that has to be perpendicular to the line opposite. Then you pick any other point. Let's take the point A, just for example, and you have to draw a line from A that is perpendicular to the line opposite. Where those two lines intersect will be my orthocenter. So it's where the red line crosses the green line. Where two lines cross or intersect is solved by simultaneous equations. So I have two jobs here: find the equation of my green line, find the equation of my red line, and I'll be able to find where they intersect through simultaneous equations. To find the equation of my red line, it's y minus y1 equals m times x minus x1. I already have the point B, which is on the red line. That will do for my x1, y1. For the green line, I have the point A is on the green line. That will do for my x1, y1. Apologies, I labeled them accidentally x2, y2, but it's x1, y1. So for both of these, the only thing I'm missing now is my slope. So I have to find the slope of the red line, the slope of the green line. I will, however, notice that the red line is perpendicular to the line AC. So I'm going to find the slope of the line AC, flip it and change the sign. So I found the slope of the line from A to C. I see that's -1. The red line is perpendicular, so I find the perpendicular slope of -1. We're going to flip and change the sign. Remember, -1 is just -1 over 1. So flip it upside down. So, apologies, our perpendicular slope is what I meant to write. Flip it upside down, it's 1 over 1, and change it to a positive, which of course is just a slope of 1. Now, for the slope of the green line, remember the green line is perpendicular to the line that goes from B to C. So I'll find the slope of the line B to C, then flip it and change the sign. I see the slope of the line BC is 1. I want the perpendicular slope. 1 is 1 over 1, so flip it upside down. I get 1 over 1 and change the sign. I get -1 over 1, which is just a slope of -1. Now I have the slopes for the red line, the slopes for the green line. I have a point on the red line, a point on the green line, so now I can fill out my formula and simplify. So once we have both equations sorted, -x plus y equals -2 and x plus y equals 6, we can now find where the green line and the red line intersect through simultaneous equations, which I'll put up here on the right. So when I stack my equations up, -x plus y equals -2 and x plus y equals 6, they cancel nicely, leaving me 2y equals 4 and y equals 2. Off to find the x value. I know that x plus y is equal to 6, so now I know that x plus 2 is equal to 6, so x is equal to 4. So I've found where the two lines intersect. That is the orthocenter. So our orthocenter here is the point 4, 2, and yes, indeed, it is actually the point C, which is equal to C. Perfect.